Bismillah wa salatu wa salam ala Rasulillah. In today's lecture, we'll talk about two different file systems, Unix and Linux file system. So talk about Unix and then about the history of Unix, the different type of distributions. Then we will move toward Linux, different type of distribution, Linux file systems, etc. So let's get started. Okay. So first of all, Unix was created in the early 1970s to be a multi-user, multi-threaded, multitask, and secure operating system. What is the meaning of each one? What does multi-user mean? What does multi-threaded mean? Multitasks and secure operating system. When I say multi-users, this means that more than one user can access the same operating system. It's kind of having multiple accounts that facilitate accessing to this operating system. So this is that multi-users mean. What does multi-threaded? Multi-threaded means that this operating system utilize the multi-threading concept. So we do know, actually, all of us, in order to explain multi-threaded, I will go to the next slide. So I will go to the next slide and then come back to this slide. So actually, we do know that a program in generic, a program is actually a set of instructions written in a programming language. So any program is a file. It's not running yet. So for example, Google Chrome is actually a program. Excel is a program. PowerPoint is a program. These are all programs. So like Excel, the Painter, a media player, all of these are actually programs. But once these programs are running and executed, it becomes a process. So what is a process? So what is a process here? Process is actually a program, but it's actually running instance of a program. So once you launch a program, it becomes actually a process. So for example, here is, for example, if I run the Google Chrome browser, it becomes a process. If I execute or run Excel, it becomes a process, etc. So this is the difference between program and a process. Program is a file not executed yet, but a process is actually an actual execution of a program. Now, what is the difference? What is multi-threading? Actually, a thread is a smallest unit of execution inside a process. So let's think about this example. I might open YouTube. YouTube is actually a program, but when I open it, it becomes what? It becomes a process. But this process might have multiple threads, 1, 2, 3. What are these threads? I can have one thread that open the video, another thread related to the translation, another thread related to, for example, one thread related to the video, another thread related to the audio, and the last thread related to the translation, for example. So all of these are kind of small tasks within the same process. And all these threads are sharing actually same resources. They are sharing the same code, the same data, the same file. So a thread is the smallest unit of execution inside a process, and each process has at least one thread. Therefore, we can see that one process might have multiple threads, and sometimes one process has just only one thread. So any process has minimum one thread. So actually, why this is very important, why multi-threading is important, because thread and the same process share the same memory, so communication between them is very fast and efficient. So in summary, what is a program? Program is just a file with a code. Process is a program that's running, and a thread is a lightweight tasks that is inside a process, and usually any process has a minimum of one thread. So let's go back to this example, to the previous slide. So we said that Unix was created to be a multi-user, so more than one user accessing the same operating system. It's multi-threaded, which means that processes are supported by threading. Multitasks, we can have actually execute more than one tasks at the same time. So for example, I can open YouTube, Excel, etc., and it is a very secure operating system. So these are all the things related to actually Unix. So they came in any flavor, and the term often used about different distribution. What is like different flavors? They are using like this Unix has multiple distributions. These distributions makes different flavors actually. So for example, I know that I would like to make a coffee. I know that the coffee is utilized with espresso, but I can add, for example, coconut milk, soya milk, low fat milk, or lactose free milk. So I know that these different distribution or these different type of milk will give us different flavor of coffee. The same thing. These different distributions has different parts that makes them different and different flavors. So this is clear, and I hope that the difference between process, task, between program, process, and multi-threading is also clear. So now let's go to examining Unix file structure. So first of all, we are talking about distribution. What is distribution? Distribution is actually a complete package of an operating system, and it includes multiple things. So distribution is actually package version that comes with a kernel, collection of software utilities that makes the operating system functional and user-friendly. For example, Windows has multiple distribution. It has Windows 11 and Windows 11 Pro. So if I go here, for example, and check Windows, Windows has multiple distribution. So it has Windows 11, it has Windows 11 Home and Windows 11 Pro. These are not different operating system. No, we are talking about the same operating system, which is Windows, but different actually distribution. This is the first distribution and this is the second distribution. And each distribution has like features. Some of them are common, but some of them are existing in this distribution, but does not exist in this distribution. So actually, distribution is a complete package of an operating system, and it includes actually kernel, which is the core operating system, software and tools, and yeah. As an example of distribution, I show you something related to Windows, but actually Unix has multiple distributions. So if this is the distribution of Windows, which is Windows 11 Home and Windows 11 Pro, what are the distribution of Unix? Unix has different distributions. It has something called silicon graphics, and silicon graphics is actually utilized for graphics and animation. We have also Sun Solar. Sun Solar is actually owned now by Oracle. We have IPM AIX, and it's still used in big companies and banks. We have also HP UX and many other distributions. So most of these actual distribution are outdated, or some of them are actually discontinued. They are not running right now, but they helped shape modern systems like Linux and Mac operating system. Because Mac operating system are actually kind of a Unix operating system. Okay, now we would like to differentiate between Unix and Linux. What's the difference between them? Now we are talking about Unix, but can I tell any Linux that is actually a Unix? What's the difference? How can I tell that this operating system is actually a Unix operating system? So the first question, is Linux the same as Unix? Simply, no, they are different. Okay, so referring to Linux as a Unix system or Unix variety is technically incorrect, or is not technically correct. The same thing is technically incorrect. Why? Because Unix should be certified. In order to tell any system that you are a Unix file system or you are a Unix operating system, it should be certified. Certified by whom? There is a group called Open Group, And this open group is actually set some standards for Unix, and it checks whether an operating system meets the Unix requirement. If yes, it gives the operating system a Unix certification. So there is something called open group. It checks whether an operating system meets the Unix requirement. Where can we find this? We can find this here. So for example, here we have the open group, and test suits who we are, what we do, what our services are. And the open group has a portfolio that tests suits that cover a complete single Unix specification. If this actual operating system meets the requirement, we can provide a certificate until that this operating system is actually a Unix operating system as well. So actually, there is a common known thing that Linux is not a Unix, which means Linux does not meet the criteria to be certified as a Unix. At the same time, Mac operating system does meet the requirement of Unix. Therefore, we can tell that Mac operating system is actually certified as a Unix. Okay. So we can go to the Open Group Center, which is the page that I just showed you. So in simple words, Linux is similar to Unix in many ways, but it's not officially Unix because it does not have the Unix certification from the Open Group. As Unix has multiple distributions and Windows has multiple distributions, also Linux has multiple distributions. So Linux distribution is actually the complete version of a Linux operating systems, and it includes Linux kernel, tools, applications, etc. And the most common things are actually Debian. Debian, one of the most stable Unix-like systems. We have also Ubuntu. Ubuntu is actually based on Debian, easy for beginner. Therefore, in operating system, I think you are introduced to Ubuntu because this is a similar version for Linux for a beginner. We have also Kali. Kali is a very good operating system for ethical hacking and security testing. We have also Red Hat, which is enterprise focused and used in companies. We have also many other actually Linux distributions. Okay. So Debian, one of the most stable Unix-like operating system. Now, the thing is that how can we examine Linux file structure? So previously, when we talk about Windows file systems, or when we talk about, Windows file systems, we said that in Windows, we have FAT, FAT16, FAT32, NTFS, etc. But what are the Linux file structure, the Linux file systems? So in Linux, there are many types of file systems that we have something called ext star family. What does that mean? This means that extension 2, extended file system, the second extended file system, the third extended file system, and the fourth extended file system. So we have this actually file system. And there are many actually file systems. There's something called XFS, which is EX extended file system, journaling file systems, B tree file systems, and many others. So each Linux distribution can choose the file systems it wants, like picking your favorite style. And actually, when you try to run any Linux on any virtual machine, it will tell you, okay, what is the flavor? Is it, for example, so we can choose the actual, sorry, not the flavor. What is the actual file system? So we know that in Linux, we have multiple distributions, such as Debian, Ubuntu, Kali, Red Hat, and there are within these distributions, we have multiple file systems. Having different file systems is again kind of a method for giving different flavors. So in order to, like, we know that we have Linux, but using different distributions makes different flavor. Using different file systems make also different flavors. Okay. Now, what is the Linux file structure? So what are the core component of Linux file structure? First of all, there is something called Linux kernel, this one. Linux kernel is like the engine of the operating system, and it is the core part that talks directly to the hardware. How it talks directly to the hardware? By the shell. Shell is the command line interface. Okay, so when I type less or who or for example ps, which is show me all the processes. So for example, here, when I open, this means that I am opening different shells. So when I type ls, this means that lists all the files. This is actually the ls is the shell, and it talks to the kernel, and the kernel talks to the hardware. Okay, so we have all of these. So actually, the Linux kernel is the engine of the operating system, as you can see, and it is the core part that talks directly to the hardware, whether it's CPU, memory, devices. So the point is that when people say Linux, they often mean Linux operating system. Okay. So they usually refer to Linux when they say Linux, they usually refer to Linux as a Linux operating system. But technically, or if we dig deeper, when we say Linux, we mean this part only, the kernel only. So scientifically, Linux means Linux kernel. But people get to use that when we say Linux, they mean the operating system. And actually, there are different example of environment where it uses Linux kernel. So Open2 is actually using Linux kernel. Android utilizes Linux kernel. Chrome OS operating systems use also Linux kernel. All of them, they are utilizing different operating system, but they take the same kernel that is in Linux and fit it to these different operating systems. So all of these run the same Linux kernel, but have different tools, have different application, different purpose. So there are different operating systems, but they use the same Linux kernel. Not the whole system of Linux, no, only the kernel, they take it and fit it. Okay. So who maintained the kernel? Who enhanced this kernel? Who developed this kernel? The one who developed this kernel called Linus Torvalds. Linus Torvalds is the inventor of Linux kernel, and it maintains the official Linux kernel. So other than that, the shell, the hardware, etc., all of the rests are built by different individual people. But the one who developed the Linux kernel is called Linus Torvalds. So every operating system, whether it's Windows, Unix, Linux, has a kernel. And the kernel is not the full operating system. It is the heart that controls the hardware. And we are given different example of operating system that uses the Linux kernel. Okay. Now we will talk about examining Linux file structure. Now, if I access Linux, I will see a lot of actually directories. Okay, so let's go. Let me delete all of these because all of these are actually taken from. Let me yeah, copy. I will move them to trash and then the rests to simplify the listing. Uh, okay. Okay. So now we will talk about different file systems. So let me clear everything and yeah. Mm. Actually, if I go to the root directory, okay, this is called the root directory. If I go to root directory, I will see several things. Like when I say cd backslash or the slash, I'm going actually to the root directory. What are there? There are multiple, when I list, there are multiple useful actually folders that we are going to talk about them right now, some of them. So one of them is actually user, which is USR. So if I say CD and then USR, what will I be able to find? I will be able to see all the applications and the program installed in the system. So if I say user, okay, and then list everything, it will show me all the applications and the all the applications and files that are installed. So if I download any application in Linux and I go to the user, like the name is actually misleading. You might say, I expect to see number of users who are utilizing the operating system, but no, I will not see user one or user two or user three. I will see all the applications, okay, installed in the system, okay, all the applications. So if I download any application, it will be shown here actually. So source, span, like exec, and include these are different type of application. So actually, user, most application and commands are in this directory or its subdirectories best. Okay. So, okay. We have also etc. What is etc? Let's go to the etc. So I will say ls and then the root directory and then etc. What is etc? etc store the system configuration. Okay, so you will see a lot of configurations there. There are actually text files. You can open it with any editor, either VI or Nano, etc. So for example, I have hosts. So this is actually a system configuration file. I can open it, for example, with VI and then hosts and then hit enter. It will show me like this, or I want to exit. We'll open another one, no worries. So cd etc ls. Let's say I will open it maybe with nano and then hosts. Yes, I open it with nano, so it will show me the configuration of this file. Um, so yeah. I don't want to overwrite any existing thing, so I should, but because I'm using Mac and then, anyways, this is like, I will quit this, but I can show you different example of, open another one and then ls, and then I will go to the directory etc and then etc, and then yeah, I can type nano and then another thing, which is, for example, maybe group. So I will see the group. There is nothing in there. It's open the configuration, but the configuration has nothing. So okay, so what we are seeing actually different configuration files. We can adjust them. We can do whatever related to them. So etc most system configuration file are stored in this directory. We are also seeing home. What is home? Home is a home directory for each user. Okay. and it's named after their username. I cannot access the home unless I have typed the actually the username. So for example, if I go here, ls, sorry, cd, and then the root directory, and then ls, I will see here home, right? So I will see cd home, and then pwd. It will show me that this home belongs to Callie as a user. Okay, so this is actually the user. If I go to oh, when I list everything, I will see all the users right now. So yeah, I will see Ahood, Guest, Hind, Kali, and Shahad. These are different users, like, and each one has its own home directory. So it contains the home folders for all regular users. So if I go, يعني, I can access Ahood, guests, Hind, Kali, and see everything. So I can say cd, and then, okay, cd permission denied. I have to type sudo, and then so in order to move to, like, because they are different user, I can't access them easily and directly. I have to properly move from one user to another user, and then like access other people folders. So I can type sudo su, and then tally. Now I am actually I'm actually in the home of the Kali, because it's kind, if I access here, there are different home for each one, but I cannot easily access them. I cannot easily access them unless I have the root privileges. Okay, so I will go back. So okay, what else we can see? So the home is the home directory for all users, usually named after their usernames. Um, we can see lists, and then I can see cd, and then Hind, because I am the root user or the highest privilege user or the administrator. I can easily go to anyone. Then home, and then Hind. So now I'm in the home directory of Hind. So I can go to lists, have desktop. All of these folders are related to the Hind. I can also go cd, and then Ahood, cd, then like this. And then list, cd, and then Ahood, and then list. I can see all the files and directory of Ahood. So usually home contains the home directory of all users, usually named after their username. So what is root? What is root? Root is very also critical thing. So root is the home folder of the root user, the super user. So the home directory for the root user, which kept separate from other users' home directory. So actually, okay, clear. If I say lists, I will see something called root. What is root? If I go to the root, I will see okay. So only actually the main, the super root can access this thing. So for example, we can say that we can access the root directory. So, and then list. So we have exam, the text. So this is kind of something for the administrative privileges. And I want you to differentiate between this and this. So the slash, this is the root, actually directory, but this is the root folder. There are differences between this and this. This is the root directory. This is the root folder. And it's very critical to differentiate between them. Okay, so actually this root folder is the personal home directory for only the root user. Only the root user can access it. Normal user cannot open it unless they become a root. For example, other users, they don't have it, only the administrator. Okay, so yeah. What else? So after we finish talking about root, we have dev. What is the device here? So the devices here, file that act as a sense ends for the device. They represent as described in chapter 3. So for example, dev sda, dev etc. What is that dev actually here? It contains uh, all the storage medium. Okay, so and the devices. So when I say cd and then dev and then ls, list everything, it will show me that, okay, I have here SDA1, SDA2, SDA3, SDA4. These are kind of different partitions within the hard disk drive. So the hard disk drive of Kali has multiple partition. If I connect my whole virtual machine with a USB, I will see the USB as another thing. There are a lot of things. Some of them are by default, and some of them are based on the connection. So this is the A1, is the A2, is the A3, is the A4, are actually the the partition of the hard disk drives. And if I have a USB, I will see this USB here. Okay, so let's go back. We have also var subdirectories such as log, often useful for investigation. So what is the var? Any application that stores some temporary files or some logging file, it will be stored here. So if I go to, let's say, cd and then var, and then lists, I will see the backup, the cache, the library, the log, the mail, etc. So any temporary file created during running an application, it will be stored here. And this is very useful in order for investigation. So if I say vi log, it will show me all of this, for example. A lot of information. Okay. So etc is for system configuration. The information about the devices installed in the system. var contains files in which the system writes data during its operation. Okay. Now we will go to another important files there. So there are some very important files there. So these are directories, which means folders that contains files. But now I'm talking about some important files, which means contain some data in there. So what are the important things? We have something called etc exports. etc exports controls which file systems or directory are shared within a remote machine. So for example, let me go to this. So for example, let me go to this. I will maximize. Okay, let me write cd, then etc, then exports. Or I can just, when I go to the etc and then list, I will see export somehow. I should see this export. Yeah, here, exports. Okay. So I will type cd, or I can like open it with nano, for example. Nano, and then etc, and then exports. So I will see this thing. So if there is anything, any communication between my device with external machine, it will be shown here. Okay. So Sometimes this is very useful because it helps investigators see which folders were exported to the network, can show if an attacker actually gained access through the network. Important in cases of data leakage or unauthorized remote mounts. Actually, there's nothing, but let me check. For example, here I can type etc exports to see some of the how it looks like. This is empty, but in real situation, no, it shouldn't be empty. Hmm. This is contains the network file share. If there is any communication between my device and the network, it will be shown here. So I'd like to see if there's any clear example of this. So it will show all the files that was exported to the network. And if I see any file, this would be very important for me to see what are the shared files from my side to the externals. Anyways, in this example, there's nothing, but usually if I have a shared folder between my device and the network, I will see the files here. Okay, so this is the thing. Okay. Okay, let me go back here. So the export file system exported to remote hosts might include remote drive mapping. So I will see my device is communicating with whom, what are the exported or shared folder with this. So we have also etc fs tab. What does it do? So FSTAP. So F means file system table. File system table. It lists all the disk partitions and how they are mounted as a boot. So I will, for example, here try to. So I will type cd and then etc and then file system table AP. Okay, it is a file, so I should not change my directory to it, but I can say the etc, and then there's something called FSTAP. So I will say nano etc, then FSTAP. So when I click, I will see all of this. What does that? This is actually the file system table lists all the disk partition and how they are mounted as a boot. Why this is important? So it will show me that we have dev, SR, media, CD-ROM. All of these are different things. So, and what type of file systems it chooses the fourth extended file system. Why it is important? Because it shows all the storage devices attached to the system. If I have a USB, it will show me this USB, external drive, hidden partition. It will show me all of these here. So it helps find suspicious or unauthorized mount points used by attacker. Beside these two files, we can see the system log. So we have var log, last log, var log, WTMP. So what are these things? The log thing, okay? So there are multiple things important here. So last log, who are the user's last login, WTMP, a login and log of history information. So I will try the last log and WTMP. I don't want to change anything. So we can change it, but I don't want to change anything. So I will say CD or not. Here is the log. So I will say CD log. Okay, so this is actually CD, I should type just log. Yes, perfect. Okay, so I have see a lot of logs here. So here's the first thing is the last log. So I can say nano last log, and I should see this last log here somehow. This is the last log. If I press enter, it should show me something, but it should show me the user's last log on. So when it was his last login, actually, if he logged in last time. Actually, there are like I have seen nothing here, but if there's like an actual login and a logout, I would be able to see some data here. Also, the WTMP login and log of history information. We have also, if I go to run a UTMP, it showed the current user login information. Actually, there's no, again, explanation of everything, but actually, I want to mention that in UTMP, it showed the current user login information. In the log, we have DMESG, which is the system message log. So I can go, for example, again, CD log, sorry, CD and then var and then var and then log. CD and then var and then log and then ls. And I can, for example, go to DMESG. We have BTMB, WTMP, DMESG. I should find it. If I didn't find it, I will not be able actually to run it. Last log, etc. It seems it's not here, DMESG. If it is there, I will be able to open it and see it together. If it's not there, it will not be open actually. But you know, all of these, you need to explore them by self and check what data are there within these things, okay? Other thing, we have a syslog. We have also shadow, group, password. So actually for the shadow and the password, these are very critical thing for the shadow and the password. So what does shadow mean? Shadow, it's very critical thing. It shows or stores all the hashed password and password related information. The last password to change, the expiration, the lock and unlock status, and it's very important, which is this one, etc shadow. So if I go to etc shadow, so and then I cd etc, okay, I should see the shadow itself. So I will say nano shadow and then hit enter. I don't know why I'm not able to see it, but I should open it. I can actually go to this file, etc. etc. And then okay, let me open it from here. CD, or I can, yeah, let me, or type nano or VI, etc shadow, or permission denied. Okay, interesting. I should actually have it with a sudo or something like this. Like, then sudo vi etc shadow, then Kali. I will see this. So what is this? What is this? This is all like, let me maximize it. It's very important. Edit zoom in, edit zoom in. I will see a lot of things. The first thing is actually a name of a username. So I will see username, and then there are multiple things here. So some of them, daemon, root, bin, sys, games, mail, etc. Some of them are actually they are called actually system accounts. So these are actually a system accounts, not an actual real accounts, okay? It's very important and it is utilized for specific purposes. So other than that, I will see the actual username. So I will see Kali, which is a username, and this hashed password, as you can see here, hash password. And what is here? I will see actually the for example, the expiration date, etc. So there are several information here. So this is Kali. This is his hash password. This one till here, till before the dots. This is a guest account, and this is the hashed password. This is a Hood account, and this is her hashed password. This is Hind account, and this is her hash password. This is Shahad, and this is her hash password. 999 means that this password never expired. If we set a specific value, this means this is the expiration date. But 99999, this means it will be never expired actually. So why this is very important, why it is very critical to understand the hash or the shadow itself, because it shows the password strength, what hash type are actually utilized. Like I can use several tools and take these hashes, and it will tell me what hash is it utilized, okay? It will show me if there's any compromised account, useful in an online or offline password recovery, hashing analysis, etc. Okay, so let's go back to the shadow. The shadow includes password-related information, but the password, there is another password, it contains information about the user. So the password is not the password. You will not see the passwords inside. Within the password, you will see the username, but within the shadow, you will see the actual password. So within the shadow, which contains the password, actually, I will see the username, the decrypted password, date of last password change, minimum required days between password to change, maximum allowed days between password to change, account expiration day, reserved some fields. So let's see this example, for example, okay? I have this. I have multiple users, root, colored, all of these are system accounts, okay? But the rest are actually real accounts, which is Kali, guest, Ahood, and Hind. So the first one is actually the username. The second part, till the colon, till here. So this is the hashed password, encrypted hash password. The third field, which is 20134, contains the last password changed in days. So I have actually to convert this, okay, to convert this into a date value, and then add to it a 1970, and it will show me that the last password was changed on 26th of October 2025. So I have to change this into actually a date time format. Okay, and this one, this 0 means no minimum days between password change. So the password has been created, but never ever changed. And no minimum days between password to change, because some of them enforce you to set 30. So 30 means like minimum days between each password to change is 30. After 30 days, we should change it. But here, there is no minimum. Like the password, once it's created, it can stay as it is till it expires. 9999 means that this password would expire after this time. But if I see a lot of nines, this means that this password will never expire. Okay. What does 7 mean? Warn a user 7 days before password expiration. So if I get 7, means warn it before the expiration. But actually, this password never expires, so there's no reminder for him at all, etc. Okay. After this, I should see some values here, but these are empty. So therefore, you will see colon and then empty colon and then empty colon, then empty. Those are 3 empty things, is that this account, no account disabled time after password expiration. So if the password has expired, disable this account, but this is not set. And there are many other things that it's not set. So we can tell a lot of information from here. This is the shadow. Okay, what about the password? The name password, you would expect to see password, right? But no, we will not see password. We will see the more information about the users as well as his encrypted password. So the password is more generic information and the shadow is more detailed information about the password. So the password is actually stores users' account information such as username, encrypted password, user ID, group ID, a user description, a user home directory, and a user login shell. So if I say here, for example, if I open new shell and then cd etc and then password, I will type again. Okay, I should open it. So nano or vi. I will see this. What is this? So this is the username. This is the encrypted password. The encrypted password is actually the actual password, but it will be mentioned as X. And then the user ID, the group ID, here's the user ID, here's the group ID. And this is actually the user description. And this is the home user of this user, the home directory of this user, the home directory of this user, and then the user login shell. This is the shell that is used for the Kali Linux. This is the shell for the other people. Okay. So we can see that they have different home directory, different shells, and etc. Okay. Now we will talk about examining Linux file structure. How can I examine Linux file structure? Okay, so the first thing that I would like to mention is that Linux is a case sensitive. What does that mean? If I write in capital letter, would be different results than if I type it in a small letter. So it's case sensitive. I should follow the rules. Wrong capitalization can mean your commands are actually rejected or unconnected. So if I say lest, I will type ls in a small. If I type ls capital, it will not be acceptable. So this is the first thing I should be aware of. Also, we will talk about different file systems there. So the first file system was the second extended file system. And then the second extended file system is one of the original Linux file systems, and it works well, but it does not have journaling. There's no logging for everything. So if the system crashes or recovery actually take longer time. However, and the third extension file systems, it adds more logging. So there is a big improvement in the third extension or third extended file system. So the big improvement, it's actually a journaling file system. What does a journaling file system mean? This is actually a feature that keeps kind of log or journal of changes before they are written. So it helps the system to recover faster if there's any crash happen. and it reduces the chances of losing some data. So the third extended file system is better than the second extended file systems as it supports journaling, file, or logging. Okay, after that, we have the fourth extended file system. The fourth extended file systems has many features, like it has 4 features. For sure, it supports journaling and it can be turned either on or off. So it can turn on or off the journaling. So I can support the recovery if there is any crashes happen. Okay. So also it added support for partition larger than 16 terabyte. So previously, they don't support partitions that are larger than 16 terabytes, but an extended or the fourth extended file system, it can manage a huge storage sizes, such as much bigger than older file systems, such as 16 terabyte or further. And the fourth extended file systems allow for larger file size, longer file systems, file names, and unlimited subdirectories. Previously, in the third extended, it allows for one folder to have 32 subdirectories, 32K subdirectories, or 32,000 subdirectories. But in the fourth extended, no, one directory can have more than 32,000 subdirectories. So the fourth extended, it removes these limits, making it better for modern systems. Also, the third advantage is that it improves the management of large files. What does that mean? Older file systems struggled like with files like 10 gigabyte video or a big data set. So if I have one file that is very, very large, the previous file systems cannot handle it. But and the fourth extended, it reads, write, and also move large file systems or large files faster and very smoothly. So previously, if you're working with a video that is 10 gigabyte or more, older file systems, they are struggling with this. They're very slow, struggle managing effectively. But in with fourth extended, it reads, write, and move them very easily, very smoothly, without any burden. Okay, so here we are just to get to know the differences between the second, the third, and the fourth. The second is the simplest one. It does not support journaling. The third is support journaling. The fourth, it supports journaling. It can be turned on and off. It supports large file system, file names, unlimited number of subdirectories, etc. Now we would like to mention something that in Linux, Unix and Linux files are defined as actually as object. So actually they consider everything as a file. So the disks are actually a file. The monitors are actually file. The drivers are actually, the tape drives are actually file. The network settings, network interface card are actually file. It handles everything as actually a file. So I can open any file and discover it further. Now we will talk about the structure of the file system, okay? Specifically of the fourth extended file system. Now, if I go back in Windows, I will see that Windows, we have, for example, the NTFS, and in the NTFS, we have the MFT. Within the MFT, we have the MFT record and many others. The same thing here. In the fourth extended file systems, we have file structure. And this file structure consists of 4 things. The first thing is the boot block and the super block and the inode and available block. What are the difference between them? In short, the boot block is related, and from the name implies, it's related to the bootstrap. So it stores all the information related to the booting, how to start the system. Super block is very important thing. It's kind of the control. It manage everything. It knows the size of the desks, how it is divided, how much space is free, how much space is actually busy. So it contains all the information about the desks. What is inode? Inode related to the addresses, and available block stores actually the data. So inode is a kind of addresses. Okay, these are addresses and these are actually the data, which called data block. So we will see these different things in detail. So here's the booting, here is the يعني geometry of the disks, here addresses, and here are data. Block is a disk allocation unit, at least 512 byte, and it might be more than 512 depending on the disk format. So here we have multiple blocks, block 0, 1, 2. And the block size minimum is actually 512, but it can be larger than this. It can be, for example, 1024, etc. So this is the blocks. And inode, we have multiple blocks, and available blocks, we have